हेलो स्टूडेंट्स। तो आज हम रेड बुक को आगे बढ़ाना चाहेंगे। रेड बुक का जो डायरेक्शन इफेक्ट वाला पार्ट था वो हो चुका है, हेलोजिनेशन पार्ट हो चुका है, मैंने यूट्यूब पे अपलोड भी कर दिया है। आज मेरा प्लान है नाइट्रेशन सल्फोनेशन के ऊपर। इस वाले पार्ट को भी कंप्लीट करना चाहेंगे। तो आइए हम कहानी को शुरू करते हैं। आपका थीम आज का है नाइट्रेशन के ऊपर। जैसे रेड बुक पार्ट है जो हम डिस्कशन करना चाह रहे हैं बी पॉइंट पे। आपका पहला क्वेश्चन सिंपल सा दे रखा है, नाइट्रेटिंग मिक्सचर के साथ में NO2 ऑप्शन दे रखा है। तो आपको बता दो गिव द रिएक्शन एग्जांपल ऑफ। तो सब्स्टिट्यूशन लेटर भी सब्स्टिट्यूशन कहलाता है, तो ये तो शायद बोलने की जरूरत नहीं पड़ेगी। इट्स नोन एज ACAR, ताकि आप इसको इसी फॉर्मेट के रूप में यूज करोगे ताकि आपको क्लिक करने का इश्यू न रहे, क्योंकि ये इलेक्ट्रोफिलिक एरोमेटिक सब्स्टिट्यूशन कहलाता है। हमने पहले भी कंसेप्ट सीख रखा है कि ऐसा होने पे आपके पास यहाँ पर एक सिग्मा कॉम्प्लेक्स बनता है, जिसके रेस्पेक्टिव हमने बात ऑलरेडी कर रखी है। अगला सेम है, व्हाट इज द नेम ऑफ द इलेक्ट्रोफिल व्हेन द बेंजीन गो नाइट्रेशन। दिस इज वेरी वेरी इंपॉर्टेंट पॉइंट। तो बेटा ध्यान रखिए, नाइट्रेटिंग मिक्सचर के अंदर आपके पास यहाँ पे ऑलरेडी डेटिव बॉन्ड के साथ में NO2 ऑप्शन अवेलेबल होता है, तो हम उसका फायदा उठाएंगे। यहाँ पे NO2 अवेलेबल है मीडियम एसिडिक के, आपने इसको बाहर निकाल दिया, ये इधर से इधर। अगर वाटर यहाँ से बाहर निकल गया तो आपके पास यहाँ पे डेटिव बॉन्ड के साथ नेगेटिव, और यहाँ पे ऑलरेडी एक प्लस अवेलेबल होता है, टेक्निकली ये +2 होता है, जो कि तुरंत बैक बॉन्डिंग करके रेजोनेंस करके अपने आप को लीनियर शेप में कन्वर्ट कर देता है। इसका नाम होता है नाइट्रोनियम आयन। लैंग्वेज पे ध्यान दिया जाए, नाइट्रोनियम आयन। नाइट्रोसोनियम आयन केवल NO+ को बोलते हैं, और NO2+ को, जैसे NO2+, इसका नाम है नाइट्रोनियम आयन। तो इसका आंसर सेकेंड आना चाहिए। क्वेश्चन नंबर थर्ड, आपको आगे नाइट्रेशन दे रखा है, CH3 आपके पास अवेलेबल है, आपको पता है इसका अच्छा खासा -I और -H इफेक्ट है। तो चूंकि हम कोशिश करेंगे कि ऑर्थोपेरा पे न जुड़े, बिकॉज ऑर्थोपेरा पे जुड़ेंगे तो सिग्मा कॉम्प्लेक्स प्रॉब्लम क्रिएट करेगा, आपका आंसर मेटा पे आएगा। बच्चा आर्गुमेंट कर सकता है कि सर ऑर्थोपेरा पेरा तो बहुत दूर है, यहाँ का पॉजिटिव क्या प्रॉब्लम कर रहा है। यस ऑफ कोर्स वो प्रॉब्लम कर रहा है, क्योंकि अगर आप इनडायरेक्टली रिजल्ट्स के बाद पॉजिटिव यहाँ बनाते हो तो ये दोनों आपस में रिपेल करेंगे, और दैट्स व्हाई दिस सिस्टम इज नोन एज ए अनस्टेबल। भले जोड़ा आपने पेरा पर है, पर केटान रेजोनेंस करके पहुंच गया ना 100 पोजीशन पे, तो आप इसको अलाउ नहीं करोगे। अगला बहुत छोटा सा क्वेश्चन है जिसका नाम है पेरा नाइट्रोटोलुइन का फर्दर नाइट्रेशन करना। तो पेरा नाइट्रोटोलुइन दे रखा है, ये ग्रुप आपके सामने अवेलेबल है। आपके पास एक +H ग्रुप है, आपके पास एक -M ग्रुप है। आपको कंपेयर करने को बोला जा रहा है, तो आप किस तरह से कंपेयर करोगे, तो उसका आपने एक बेसिस ऑफ फंडा अप्लाई कर रखा है ताकि आपको डील करने की आसानी हो जाए। या तो हम उस कहानी को कैसे डील करना चाहेंगे, तो हमने सिंपल सा फंडा यूज किया हुआ है, क्योंकि +H इफेक्ट है तो उसकी ऑर्थोपेरा, यानी हम ऑर्थो की पेरा तो ऑलरेडी लॉक है, तो हम ये जीत पाएंगे। ऑफ कोर्स यहाँ पे तो जो नाम बेवकूफी को से मेटा डायरेक्टिंग है, आप किसी भी हाल में अपने आप को चेंज नहीं कर सकते इस फंक्शन में। और अगर पेरा दे रखा है तो आप यहाँ पे लोकेशन चेंज नहीं कर सकते, ये तो सही है, पर ये लोकेशन चेंज कैसे हो सकती है। तो आपके पास कोई ऑप्शन नहीं है, ओनली 4 का 1, दैट्स द आंसर। क्वेश्चन नंबर 5 आपसे क्या पूछा गया, आपसे पूछा गया एमईओ के बारे में कि आपका एमईओ का ऑप्शन क्या कहलाएगा। तो हमने उसी कंसेप्ट को फॉलो करने की कोशिश करी इस समय। तो जब हम एमईओ के कंसेप्ट को फॉलो करना चाहेंगे तो उस सिचुएशन में हम ये कंपेयर करेंगे कि आपके पास HNO3 अवेलेबल है, ये आपका +M इफेक्ट है। वैसे यहाँ पे +H इफेक्ट भी है, बट +M और +H में +M को डोमिनेंट मानेंगे हम यहाँ पे, और यहाँ पे एन कैरेक्टर रखेंगे ताकि हम अप्रोच कर सके। तब सोचो यहाँ ऑलरेडी पहले से ग्रुप जुड़ा हुआ, तो यहाँ जोड़ने पर स्टिक थोड़ी ज्यादा हो जानी चाहिए। इसका मतलब हम इधर जोड़ेंगे तो स्टेरिक ज्यादा, लाइक दिस ऑप्शन मैच नहीं कर रहा, क्योंकि आप यही जोड़ पाओगे, देयर इज नो अदर ऑप्शन इज अवेलेबल। तो यहाँ जोड़ना तो बेवकूफी कोई जिंदगी नहीं है। तो ऑफ कोर्स सिग्मा कॉम्प्लेक्स के हिसाब से आपका आंसर यहाँ पे थर्ड आना चाहिए। क्वेश्चन नंबर 6 आपसे पूछा गया मेजर प्रोडक्ट ऑफ द फॉलोइंग रिएक्शन। आपके पास ऊपर ध्यान से देखो, ऊपर की ओर एक अल्फा है, नीचे के लिए 3 अल्फा है। अल्फा इसके पास ज्यादा अवेलेबल है, इसलिए अल्फा की ओर से ज्यादा अच्छा नाइट्रेशन होना चाहिए था। ये गलत ऑप्शन है। आपके पास सिग्मा कॉम्प्लेक्स जब बनाओगे तो नाइट्रेशन ही प्रीफर करोगे, बिकॉज द बेसिक प्रॉब्लम इज दिस कि whenever we just draw the sigma complex, then sigma complex will be more stable by the hyperconjugation. There is a 3 alpha hydrogen in the compound. That's why this compound show hyperconjugation. That's why we can say that's a, it's known as a more stable form, because the sigma complex will be having the more the number of alpha hydrogen. So overall, there is the answer is about 2. Okay. Next question number 7, a very simple question. Ring nitration of dimethyl benzene. This is the formation of only one nitro dimethyl benzene. This is a very, very important point. Only one nitro dimethyl benzene. Then we have to identify about the dimethyl benzene in which only one portion will be possible. Find the option number 1. Just think about this, about the +H effect. That's why we have to consider only an ortho and para. And again, there will be the ortho para. It means there is a two type of position is available with the next nitro group. In the same pattern, if there is a metajalin, then we have to consider like this one, and this one. Don't consider this one because this one and this one is symmetrical. So there is a three type of options are available. In option number 3, there is a plus H effect, That's why we have to consider this will be the ortho position. Again, from this methyl group, there is also ortho position. So we have to consider that all the four position will be same. Either any situation will be available. So only one nitro product is available like this. This is known as a one nitro group. So I think this is the answer about the 3. There is no issue. It's a very simple, highly symmetrical, and there is also a trick. Ortho means 2, meta means 3, and para means 1 position. Okay, we have to consider like this. The next question will be about the para-methoxytoluene is nitrated. So we have to know about the para-methoxytoluene. So we have to know about the plus H effect. That's known as a plus M effect, and plus M effect will be more dominant on plus H effect. So direction effect will be by the plus M effect. This is your NO2 group. I think the second will be the answer because your plus M effect will be more dominant for the nitration. Okay. Next question number 9. We have to know, consider what is this. This considers the electrophil substitution reaction in which nitration, which of the following sequence regarding the rate of reaction is true. Now the problem will be about the C6H6, C6G6 and C6T6. And the concept is about the nitration. So we have to know that nitration do not show isotope effect because your graph represent like this. Now here that will be considered as the H or D or T, but the RDC shape is another. So in this situation, either break by H, either break by D, either break by T. There is no difference in the rate because RDC shape is having the maximum energy, then this will be known as the fast step. So in this situation, we know that here in nitration, if there is a hydrogen, deuterium, tritium, anything is available, then there will be a sigma complex, then HGT, any atom will be break by, we know very well that deuterium and tritium is with a very strong bond with respect to hydrogen, but the problem will be this key, this type of bond energy will be very less considered to the RDS step because in the RDS step there is a two type of bond, pi bond, energy loss will be available. That here is the energy gain will be available. So gaining nature is much more higher. So any bond break about the H, D or T, there is no effect. So that's why we have to consider that third is your answer because there is no isotope effect. Isotope effect will be considered for the sulphonation and iodination in aromatic compound. This is a very fundamental trick you have to know. Next, the carbon atoms of benzene are, I think, it's a very time pass question about the sp2 hybridization. There is no issue. I think this type of silly question will be asked in the mains also. Next question about 11. There will be a group. One is OH, one is COH. We know very well. This is a plus M, this is a minus M. And now I have to consider about the HNO3-H2SO4. It's known as the nitration. We know very well. Plus M is known as the activating group. That will be more preferable for donor. So OH will be more donor side. That's why we have to consider like this. There is a we have to know about the orthopad acting, but there is a lock because there is already a group is available here. So there is a two type of options are available. We can say the ortho and para. And due to steric crowding, ortho will be known as a steric crowding situation. So we have to consider para. Para from OH group. This is very important. Para from OH, not possible here. Para from OH, not possible here. Para from OH, yes, this is the possible situation where answer will be, I hope 3 is your answer because plasma effect will be more dominant with the nitration and that will be considered as a more donating group. We can say there is a sigma complex that will be more preferable or more stable form because of the following situation in sigma complex. Just think about it. There will be a one OH and we have to know about the sigma complex like this. There will be a positive and this is a complex. That's the sigma complex. Whenever the positive charge come to the ipso position of OH, there will be a backpi bonding and the octet complex, sigma complex will be more favorable. That's what 3 is your answer if you just go into depthness. Now the question number 12, that's a very simple and fundamental concept about the chlorine sunlight because this situation will be the creation of chlorine radical. Now there is a problem about the 3 alpha, about the 1 alpha, but just consider there is a 2 phenol also. That's why this will be more preferable because that's a 3 degree and 1 degree. and we know very well 3D radical will be more preferable on 1 degree radical. So we have to consider like this. But there is some issue about the excess. Excess means we have to consider all the situation. So there is a lack of this H. This that will be converted into a Cl. Here Cl will be not possible on the benzene ring because we have to consider alpha. There will be 4 alpha, so we have to consider 4 alpha halogen like this 3, and this one is Cl because there is a radical formation that will be considered as a more stable form like this. Because this is a resonance form, this is also known as resonance form, and resonance that will be a more preferable situation. So we can consider that all the alpha hydrogen replaced by alpha halogen, and your answer is third here. Okay. Next question number 13, we have to consider about the phenol, zinc dust, then nitration, then zinc with NO. That's a very unique option. We have to know about the concept. Now the problem will be zinc dust is this, so we have to consider like phenol is available. If there is a zinc dust, it's a very patent permanent question. There will be replace of a zinc oxide and the phenol convert into a proper benzene. Now there is a nitration. Then if you consider about the nitration, this is the nitrobenzene. Here is the nitrobenzene. Now there is the information about the zinc with NaOH. That's a very fundamental and basic concept about the basic medium reduction. That's a, I think it's a rectification for a some type of moment because in acidic medium like Fe with HCl or Sn with HCl, we just consider about the aniline. But if there is a basic medium, nitration, reduction, then that's the theme of hydrobenzene because aniline is not possible here. The single theme is hydrobenzene. It's a hydrobenzene because in basic medium we have to consider like this. Hmm, this theme is a hydrobenzene. I hope you understand about this. ये आपका बन गया, this is known as a pH and nitrosonium ion, and the theme again we consider the pH NaOH, and that will be interconvert into this. Then the formation of a dimer type of pattern, and there will be the answer. Again, there will be a water replacement, then this, then nascent oxygen will be dropped, then this, then there's a consider of the hydrazobenzene. That's the proper rectification, and that will be, I think, in the convert into the advanced. Mains level, pe, there is no requirement to remember like this because such type of questions for advanced. And in next time, I will be shift to green book this question. Okay, okay. Next point. In question number 14, the following reaction, there is will be the structure of the major product. We have to consider about this. There is a plus M effect, there is a delta positive, that's known as a minus M effect. Here also NO2 is again a minus M effect. So we have to consider the plus M effect because 50-50, but 50% will be more preferable on deactivating group, that's known as the activating group. And there will be electron density more at ortho and para position, and due to steric crowding, ortho will be less preferable than para. So we have to consider para position from NH, not this like this. We have to consider like this. Yeah, this is the para position that will be the more preferable situation. Okay, so this is the basic funda. I hope in question number 14, NO2 is not available because I think this NO2 is extra because in the option there is no NO2 group. So I think NO2 is not available here. We have to consider only the plus and minus. I think the question will be like this. This is the name of a amide group, and we have to consider like this. The question must be, I think, this because no double NO2 is available here. So I think compound will be changed. Now there is a 15 question about the aniline, then anhydride, then nitration, then again hydrolysis. Such type of situation will be available. Then acylation, you have to just not deactivate the aniline group so that orthoparahol portion will be not consumed, only para portion will be consumed. So here aniline is available. We have to know about the anhydride formation like this. We just convert into acetanilide, that's known as the amide situation. Now there will be a NO2 group, this is known as the nitration because this is a very bulky group, steric crowding is available. So ortho position is not possible. Then we have to consider for the para position, and we have a para nitroanilide like this. This is known as a para nitroanilide. Now again hydrolysis is available. Hydrolysis means again SNA reaction. So in this situation, just think about the hydrolysis about the AH and OH. Then again NH2 will be available. So simple. One side is NH2 and para portion is NO2. I think this is the answer. About the second, your answer is second here. Next question number 16. If there is a COCH3, it means there is a minus M group. If you consider about the nitration, because there is a deactivating group, so there is no other choices available. Just think about this about the nitrobenzene. Now this is the theme of a Clemmensen reduction. In Clemmensen reduction, all metal and acid is available. So NO2 also interconvert into NH2 and keto is also convert into CH2 group because that's a Clemmensen reduction. So we have to consider about this CO is converted into CH2 and NO2 considered into NH2. So we have to consider like this, yeah, CH2 and this is known as NH2. I hope your answer will be a third is the best choice in the following situation because in Clemmensen reduction, NO2 will be not possible to exist as a NO2 group, and second keto is not possible because all will be reduced immediately because this is the theme of excess of zinc and excess of H plus. Now question number 17, we have to consider about the which of the following compound undergo the nitration at the fastest rate. So we have to know and consider about this because again fastest rate it means more the plus M effect because we know about the plus M plus H plus I that will increase the electron density of benzene. Here there is only 2O2 4 alpha is available. Here there is a perfect plus M and plus H is available. Here plus M is available, but the power is just reduced to 50-50 because lone pair considered to both sides. Here direct lone pair is not available, so this is the represent of minus X deactivating. So fast check in the order there will be orders about second, then third, then first, then fourth. Because we consider about the fastest rate, so that's why second is the best answer. Now question number 18th, that's a very good question and tough question also because it's not a cup of tea for everyone. Yeah, just think about this. There is a benzene and we have to know about the alpha hydrogen because there is a steric crowding. So and here not possible. Just consider about the para position. So in this situation, we have to consider about the sigma complex. So like this. This is your sigma complex where we have to consider about the NO2 and H and this is known as a positive positive. Now this positive will convert into this side and this will be again either the two ring aromaticity loss but then we can say it's not a loss. So in this situation there will be considered the sigma complex from both para location like this. And this one there will be a NO2 group, there will be an H group is available, NO2 plus. This one, and there will be one H, and this will be considered a positive charge. Now there is a basic issue about the sigma complex character. How can we identify such type of situation is available? Because we just imagine that there will be considered as the aromatic compound. Aromatic situation is always available with this. So this is a re-aromatic, but how can we identify this HH? So there is will be HNO3, that's known as the nissanct oxygen. This is known as the oxidation oxidizer like this. Just remember like this. So this is the sigma complex which will be easily removed from the situation. And this is the theme of aromatic, but the problem will be like this: how can we replace such type of thing into aromatic compound? This is the problem. So we have to know about the nissanct oxygen because in HNO3 there will be a nissanct oxygen is available, which is known as oxidizer. So again, this bond, this from this bond H minus is available for oxidation. This is the theme of oxidation from para-benzoquinone type. So again, there will be the answers like this. That's a very unique option because this step is be not a cup of tea for everyone. This theme is also oxidation because the net result will be aromatic situation. So in 18, there will be the second will be the answer. Indirectly, we have to say because in the last step, sigma complex will be again oxidized by HNO3 and formation of a re-aromatic compound, and water will be the end product. That's very important. Next question, there will be a OCOCH3 group is available, then it's a AlCl3. I think this is also the advanced level because it's a theme of a price rearrangement. If there's a price rearrangement, then we have to know about there will be OH and there will be a COCH6 known as the ortho position. This situation is known as a iodoform test. I think it's a advanced level, you know. Then an iodoform test in future we have to consider, but right now we just think about this that will be converted into a COH group because this CH3 will be converted into ON and H plus is available than COH. Then I think it's known as the salicylic acid. When we talk about the bromine water, so I think it's the theme of ipso substitution. If you remember the concept, if there's ipso substitution is available, then again decarboxylation is available at orthopara position. So just replace three bromine is here. I think 19 answer will be third. Yeah, the 19 answer will be third. So I think we have to consider about the third situation where all CO2 will be replaced and in ortho and pora position there will be a bromination. So we have to consider about the tribromophenol. We can say it's a white PPT formation. So this shape is a quite sticky and tricky, but I think that will be much more preferable way. And next one is the informative pattern about the iodoform test. In future we will talk about this, but right now just think about the iodoform test and in methyl keto group convert into a COH group. That's a very basic step because question is perfect. Okay, that's a very good question from the I think it's the advanced level, not a mains level. And the last thing, but not least, about the 20 question, we have to consider about the major product obtained when orthonitrosobenzene is treated with chlorine in presence of Lewis acid. Say orthonitro, I think it's the orthonitrosonitrobenzene. Okay. Then we have to consider about the NO2, then also consider about the NO. It's a nitro, it's a nitroso. But we have to know this is a perfect minus M, but this is minus M and plus M both. So this is the basic fundamental concept about the sigma complex, and we have to consider like this. Now we have to consider about the chlorination. So because of steric crowding, this ortho will be neglect, and this will be not possible because there is no H. That's why only this portion is available, where H will be replaced by Cl. So NO and Cl will be at the para location. This ortho not possible steric crowding. This is the meta not possible. This is your NO and this is your Cl. That's known as a para position. So we have to consider about the third location. So all about this is the theme of nitration. We just discuss about the nitration and the remaining 8 question about the sulphonation. That's also we have to consider. So in the first question, yeah, such type of discussion is also available because so many files will not be in a one folder. So I think in Redbook, 2 or 3 topics will be in the one folder. So I think you just search by a easy way. So the first question about in the sulfonation of benzene, the active electrophilic species is active electrophilic species is known as SO2 group, is as a SO3 group is known as a sulfur trioxide. That's a very informative pattern concept, but we have to know about because it's the theme of dehydration. So if you consider about this, so just think about it. If one is OH and one is OH, just replace water molecule, then there is a formation of a sulfur trioxide. This is your electrophile. That's a very simple basic thing. In future, I think in past you already know about the sulfonation because 2 mole H2SO4 is available for 1 mole of SO3. But right now, that's a thing that's a very much more sufficient. Now the second question, reaction of SO3 is faster in. So that's the benzene, toluene, that's known as the plus H effect, nitrobenzene, that's the minus M effect, chlorobenzene, that's the minus I effect. So we have to consider about the plus H effect. That's why more the donor power. And there is also order of the rate of reaction about the electron substitution. Then we have to consider about the plus H, then consider about the benzene because that's a neutral, then minus I, then minus M. That is your order. In the next third option, there is a problem about the reaction C6H5Y. The major product 60% is meta isomer. That's a very, very important situation. For condition about this 60% and more will be meta isomer. So the group Y will be. So just imagine about this. That's known as a minus M. That's known as a minus I. That's known as a plus M. And that's known again a plus M. But there is the problem in strong acidic medium that will be converted into a strong minus, and that's a very important concept. So I hope in sulfonation, yeah, both options are available about this and this. But here is the equilibrium. I think you know about the nitration. Just consider about the 51, 47, and which if you remember about the 2%. So there is the equilibrium. But this is a 100% minus. There is no choice. No option is available. So we have better to prefer this. In class, just consider about this. If you just hitting, then there is the theme of Hoffman-Martius reaction, where para is the major product. If you remember about this, aniline ion is available, but on H2SO4 heating, that will be again convert into Hoffman-Martius reaction is known as a uh, sulfonylic acid. So just consider this ki this will be not appropriate because strong minus I and plus and both is available. So answer will be both. Here 100% deactivating group. So yeah, the point is 60% and above. That's a very good situation because it shows that there is no equilibrium formation. Okay. Number four, which is the following will undergo sulphonation at fastest rate. So just consider about this. They will be known as a 0 alpha, there will be a 3 alpha, there will be a 2 alpha, there will be a 1 alpha. So more alpha, more stable sigma complex, more the rate of reaction. So I think that's the fastest rate. We have to consider about the second. And the order is very simple about the 2, 3, and this is last as a 1. Okay. In the question number five, we have to consider which of the following is the most reactive towards sulphonation. So that's known as a MAPO meta para orthogelin because meta situation sigma complex will be more favorable or stable form. So metagelin will be more preferable. Why metagelin is more preferable? Because we know very well that whenever in metagelin if sulphonation is available, we have to consider about the sigma complex. Then like this is your situation, and this positive will be converted to this, and we have to consider about the 6 alpha hydrogen. So that's a more preferable situation where more the alpha hydrogen, more the electron density is available. So I think metagelin will be the more preferable form. Okay. In question number six, just consider about the question number four. We have to. This is the question number six where you use the sulfonic acid. This is the concept. Stated is excess of bromine water. What will be happen? So in the question number six, what will be happen in this? So this is the theme of ipso substitution. If we have to consider about the NH2 and consider about the SO3H, and there will be known as the bromine water. Then we have to know about the ortho, para, and again para position is also engaged, and we have to know about the ipso substitution. So there will be tribromo product, and one SO3 will be evolved as a gas. So the answer is tribromo product. This theme is also ipso substitution. This question is come from ipso substitution process. Now that's a very fundamental concept about the alpha and beta attack. I think sulfonation is a best example for this. When there is a low temperature about the 40 degrees centigrade, we have to consider about the alpha location because alpha complex will be more stable form like this. But whenever the temperature is 120, then there is a problem about the steric crowding because this bulky group will, whenever just rotate, then there will be a steric crowding possible. So in this situation, at the high temperature, that will be again revert to naphthalene, and the best product is beta location because in this situation sigma complex will be available, but there is no steric crowding, much more steric crowding because there will be a large gap in between the situation because this H and this H will be at the 120-degree angle. So this bulky group is easily confirmed in beta position. So at low temperature alpha is much more favorable, and at high temperature beta is much more favorable. So the answer is alpha and beta. Okay. Next question number eight. There is a question about the H2SO4, then chlorination, then hydrolysis. So I think whenever in the electrophilic side, first and third will be this. So we can say this type of reaction will be the para blocking type of reaction. So if there is the H2SO4 is available, so we have to consider about the SO3H. Then there is the chlorination. Then this is the theme of chlorination. So here para position will be blocked from some same side. Then there is the ortho position is available for because only ortho is free, and after hydrolysis just remove this sulfonation and the compound is converted into like this. So your answer is again option number C. So I think about this that we have to consider about the sulfonation, nitration. So the next option will be consider as alkylation. So let's start about the alkylation also. So will be easy choice to convert this. Now there is the alkylation. Simple one question is available, which is the following compound give poor yield of Friedel-Crafts reaction. That's very important. Poor yield of Friedel-Crafts reaction. So we can say is the drawback of Friedel-Crafts alkylation. I think here NH2 will be converted into, yeah, that's a poor yield pucha, that's a very important for us. So just imagine only NH2 need, no, because this is the theme of minus M, there will be a 3 minus I group, that's even also known as the minus H effect. And NH2 convert into NH3 plus, that's a very strong minus I, and all of these available. So I think all of this is the answer because in Friedel-Crafts reaction, deactivating group, especially strong and mild deactivating group, will be very poor yield for Friedel-Crafts reaction. Now, question number second, which of the following compound give benzoic acid when react with hot caminophore? So, very simple funda. If there is a 1 alpha hydrogen is available, here is also 1 alpha hydrogen available, here will be COH available, then all will be converted into directly into benzoic acid. That's why your answer is about the all of this. Next question, that's a very important question. There is a silly mistake is also available. There will be a 3D example is available. Phenol, that's a very strong bond, so we can't break in the normal situation. So we just consider about this acidic medium, about the oxonium ion, and this will be bond break. Future step, you have to consider the SN1 type of reaction. So we have to know about this carbocation that's known as a stable carbocation, and also consider the phenol option like this. यहाँ पे phenol is available. नाउ सेकंड ऑप्शन इज यहाँ पे ये अवेलेबल है आपने फिनोल का ऑप्शन यूज किया दिस थीम इज नोन एज ACAR वी कैन से electrophilic aromatic substitution so if plasmic group is available so there is no requirement of any Lewis acid requirement and that's the best bhikari so in this situation just consider about the sigma complex because it's a very large group so of course para will be the major product so that's why your answer is like this in this situation, in this question, there is a two type of reaction will be available. First type of reaction is known as the nucleophilic substitution, and second type of reaction is known as the electrophilic substitution. So both steps are very nice, and I am waiting for a long time that such type of question will be preferable for in your future FAQ question type. So I think that's the SN1 and also known as the electrophilic substitution. So there will be a new sigma bond formation, and this is your best answer in which state crowding will be quite less and that's a very important question. Okay, in the next question number 4 there will be a chance about the preparing monoalkyl benzene acylation process is preferred and that alkylation why so we have to know about it one heading is available in the class notes polyalkylation because we want one time and God give so many times so if 1:1 ratio is available even though product will be more reactive so mole concept cannot follow and the product will be 1, 2, 3, and 4 like this. We have to consider so the single and consider this a polyalkylation. So just think about the option. In alkylation, poisonous gases evolve. It's a very wrong option. Alkylation, large amount of heat is evolved. That's a very long option. In alkylation, polyalkylation product is formed. Yeah, that's the answer. And in third, it will be the answer in future part. Okay, so that's a very important and easy way to explain about the third option. Next question, benzene react with N-propyl chloride in the presence of N-hydroxyl to give the predominantly. So in N-propyl chloride, there will be a AlCl3 is available. We have to consider about the Lewis acid base concept. Dative bond is available. There is a negative and there will be positive. Just cut this bond. There will be a partial positive charge and that will be converted into Lc4 minus, but partial covalent because such type of partial covalent partial ionic character because 1D keton is highly unstable, but immediately shift by 1 to hydride shift. So there will be a stable 2D carbotan. In this question, there will be predominantly, it means major product considered So like this, it's a simple theme of Fidelcraft alkylation, and the answer is isopropyl benzene. Yeah, we can say cumene. So I think your answer is second here. Next question number six. The major product of the following reaction. Again, the same pattern is available. The compound will be plus same effect. Loose dative bond will be available. We have to consider about this delta positive because full-fledged positive is not possible. So immediately hydride shifts. So there will be formation of a stable cation. And the para location is always available for this. So just think about the para location. This is your sigma complex, and that is your answer about the fourth option. So I think fourth will be the better choice for this. Now in question number seven, I think there's again a same repeat question, just form a dative bond. So cation will be like this, that immediately hydride shifts. So cation will be 2D cation. Then benzene will be available. If benzene will be available, then there will be a complex about the sigma complex. And secondary butyl is available. Now the problem will be your answer is none of this because this is isobutyl, this is the tertiary butyl, this is the N butyl. The answer is secondary butyl. So I think none of these, yeah, much more better like this. Like this is your answer. You are so lucky then that diagram is also available in the option. If I just want to change the concept or theme, then I just think about the isobutyl, secondary butyl, tertiary butyl. So the question will be converted into a much more better way. So think about the common name also. Okay, that's a good question. Now, which is the following structure corresponding to the product extraction when the excess of C6H react with CH2Cl2 in the presence of AlCl3. So that's a very unique option because there is a two type of chlorines available. In the first step, there will be formation of one bond. So one dative bond is available. We have to consider like this. This is the sigma complex pattern formation starting, and there will be dextrizine taken the formation of like this. This is not your product because again AlCl3 because it's behave as a catalyst again react with and the formation of a benzyl carbocation. Again, next other benzene will be available for the sigma complex reaction, and we have to consider about the two phenyl group like this. Luckily, two group is available here. That's known as a diphenyl. And the unique option about the IUPAC name we have to consider as a 1,1 diphenyl methane. So I think your answer is 4 is here. Same question which the following gives Fidelcraft reaction. Fidelcraft reaction is a very unique option. So your answer is again first because we know very well that will be converted into strong minus I. This is the minus N. This is again a strong minus I. And we know about this that a deactivating group do not show Fidelcraft reaction. So strong deactivating and mild deactivating means no Fidelcraft reaction. Next question is which is the best method for the prepare of the following compound? That's a very good option. First step is nitration here. So just think about nitration. Now we have to consider about the Fidelcraft alkylation, but this is not the right choice because deactivating group do not show Fidelcraft reaction. In sector, this is not possible about the answer. The second option is available. We have to consider about the Fidelcraft alkylation like this. Again, there will be nitration, but if nitration is available, so we have to consider about the orthopera because it's a very bulky group. So I think your answer is second. Now there's a problem about this. What's not possible about the third option? So in third option, there will be a 1D cation will be available, even partial, then convert into 3D cation. When benzene will be attacked, so I think that's a major that, but also considered as a minor product also. But in this situation, only 3D will be your answer. So I think question will be the best method. So best is those in which no need of separation. So here second will be much more better because only one type of electrophile is available here. And in third option there will be a two type 1D and 3D. So mixed product will be formed and in future is a separation. Again this is not possible about the nitration. So the appropriate answer is second here. Question number 11, there will be a plus M effect. Just think about the lone pair. Think about the plus H, and we know very well plus M will be more dominant. Here, alkene is available for acidic medium. So just think about the cation, and this is your choice about the plus M effect. So I think this is the sigma complex, and this is your answer. There is no other choices available. plus H is not possible. If alpha location, so this is impossible because in electron substitution, reaction on benzene, not out of the benzene. In question number 12, that's also a good question. So just think about the sigma complex, then benzene, just about the Fredcraft alkylation. Your answer is like this. This concept is known as a Hubbo. It's about the hydroboson oxidation. We can say it's anti-Markovnikov with hydration. So just imagine like this. Your option is available. Here is H and one other is OH. Now there is a HF is available. That's also we consider as a Lewis acid. So in Lewis acid situation, there will be H, there will be positive, and benzene again attack. It's known as an intramolecular Fiedel-Crafts reaction. We have to consider as a intramolecular Fiedel-Crafts reaction. So there is a formation of like this sigma complex. There will be positive, and at the end, immediately aromaticity again regain. And your choice is like this because two times Fiedel-Crafts reaction possible. So that's a good question. Third is your answer. So first step is a simple Fiedel-Crafts alkylation. Second is known as the HBO, and third will be again Fiedel-Crafts alkylation. Question number 13. This question is from Gignard. We can say it's a type of a Wurtz type of reaction. Yeah. So here, just a take from this side, single electron transfer, that will be the answer. So we have to consider about this, about the 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Then we have to consider about the CH2 MgBr like this. That's the negative, that's the positive. And here there is F and there will be NO2. Now, it's a very basic concept about this NO2 is a deactivating group. So there will be a positive charge on the ring at orthopara. And there is an anion. So immediately one anion attack on carbocation position. So fluorine just replaced from this carbon. We can say the fluorine is a bad living group, but here fluorine is very good living group because this minus side will be considered as a more positive. And if more positive is available, then more negative here attack. Just think about the numbering also so that we give the best option about the 1, 2, 3, 4, 5, 6. Luckily, 6 numbering is available and this group is converted into a sigma complex. I hope your answer is, but this is not possible because of steric crowding. Your answer is like this because this is a sigma complex. Yeah, that is the answer. The answer will be 4. Because here only two group is the existing portion and there will be a gap about the H portion. So there is a very less steric crowding. Rather in third option, there will be a much more street crowding. So I think 4 will be much more better option. In next question number 14, there will be a 3 NO2 group and 1 CH3 group and the compound is chrome H2Cr2O7 is a potassium chromate and H2SO is a good oxidizer. So I think the alpha H position is convert into alpha COH position, just convert into COH group. Like this, ये आपका answer like this nitrobenzene and there is a COH group. Again, the second step is soda lime process here where CO2 group will be replaced into H group. So I think this is the theme of here will be H and this is the theme of decarboxylation. The compound is TNB trinitrobenzene and this is an explosive compound. So the best answer is 4 here. Next question number 15, give the major product of the following reaction. If the compound is this situation, then immediately follow the Markovnikov and Markovnikov just consider about H and there will be a positive charge. But immediately, I think there is hydride shifting that will be much more better because if hydride shifting is available here, then there will be carbotan that will be considered 3D carbotan. That's a much more better or stable form. Again, the benzene is available, which convert into a sigma complex and last appropriate answer is like this. So simple, it's a Markovnikov. We have to consider the Fiedel-Crafts alkylation. So there is a requirement of a carbocation. Now in alkene, follow the Markovnikov. H just add the edge pi bond, then cation, then immediately hydride shifting. That will be much more better because 2 degree cation and 3 degree cation, we have to know 2 degree cation is 2 degrees much more better is the 3 degree carbotan by 1 to hydride shift. So just format 3 degree carbotan, then benzene will attack here and the sigma complex is there. Next question number 16. This is the theme of a very unique option about the Claisen rearrangement where 6 member cyclic transition state is formed because there is H is available, one is and one is. No solvent, no reagent, only heating is available. So in this situation, the formation of a sigma complex like this, here is the H and this is your option like this. Again, just theme the tautomer, and tautomer means aromatic situation. So your answer is like this. Again, this is converted into a para location also, because again there is a 6 members agreed. I just shift this group into in this situation like this. There will be H, and this is your option. So again, this is 6 members cyclic formation. Think about this. 1, 2, 3, 4, 5, 6. Again here, here, and here. So your sigma complex, it will be again interconvert into a para location, and your answer is like this. And there will be a pi bond in this, and this is also considered the tautomer. Again, this is your answer. The such type of because the existing group on oxygen will be interconvert into an ortho and para position. Such type of arrangement is known as a Claisen rearrangement. That's a very oldest paper of advance in very past, na very past. So I think just imagine one example. So mentally prepare for TK means. Now there is a QH. So simple acid base reaction will be here. Minus is available. Just heat. This is the theme of cyclization, because they will proper mention this situation. There will be considered as a 1, 2, 3, 4, 5, 6. So this is your 6 member ring like this. Again, there will be nitration, because this is the minus I effect, because here is the CH2, here is the CH2 is available. So much more better to consider as the ortho para position of upper CH2 group. So this is the ortho, this is lock, and this is the para, because 3 group is not available here. So I think this is your better choice about the second option. Next question, major product about this. Such a reaction, there is a 0 alpha, there is also a 0 alpha, there will be a 2 alpha. So this is your ortho position, because para lock here already, and this ortho is locked. So just imagine about this. Here we have to consider. But what will be considered? Just loose acid base, then carbocation, and this carbocation will be at the para position. Yeah. So I think much more answer is about the fourth. None of these, I think there is a correction. Because I think your better answer is like this. This is the benzene, there will be a group, there will be tetrabutyl, and we have to consider about the COPH group. Now such situation is available. We have to consider about the LCH dative bond, then hydroxyl diawire. That's why we have to consider about the sigma complex and the formation of a CH2, CH2OH. Again, there is the H2SO4. We have to consider about the E1 and E1. It means formation of a styrene. Then chlorine water is available. Then we have to consider about the Markovnikov non-classical carbocation. There is a Cl is available. Water consider from this side, and this will bond break. So your situation here, that will be OH, and here will be the Cl. Again there will be again acid base reaction. Again acid base. Then again minus is available. Then just attack from this side, and there is a epoxide ring. I think one carbon will be extra here. So here will be O minus, that will be attached from this side, and this is the theme of neighboring group participation, NGP type of reaction, and your answer is like this. Yeah, in the same 20 options available about the, this is again a Claisen rearrangement. So we have to consider about the this one, this one, this one. There will be a 14, and there will be deuterium is available. Here deuterium, this side, and this side. This is your sigma complex type of situation, and there will be a double bond. Again, this CH2 is available here, and there will be something as a pi bond also. That's a 12, and 14 will be away from this side. Again, tautomer will be a best option. So we have to consider about the OH, and 12 will be here, and 14 will be above. It means there will be a deuterium, and 14 will be far away from benzene. So this is your one answer. So I hope you understand about the sulphonation, nitration, sulphonation, alkylation. This is the second part of aromatic substitution in that book. Have a good day. Bye bye.